All right, today we're going to learn how to name binary molecular compounds. So this is going to be a little bit different from ionic compounds. So binary molecular compounds, the word bi means two, molecule means two nonmetals. So that's going to be really crucial in recognizing when you need to use this type of nomenclature. It's only when you see two different nonmetals bonded together. So here are the examples that we will be looking at. You see in these examples, N and P, nitrogen and phosphorus, are two different nonmetals. For H2O, hydrogen and oxygen are two different nonmetals. And CCl4, you have two different nonmetals, carbon and chlorine. So for naming binary molecular compounds, you're going to write the names of the two nonmetals. You're going to change the ending of the second nonmetal to "ide." This is just like you did with binary ionic compounds. And then you're going to add, this is the part that's different, you're going to add prefixes to the beginning of those nonmetals to tell me how many are present. Now the reason why we have to do this for molecules is because they don't have charges. If you remember from how we named ionic compounds, we were crisscrossing those charges in order to tell how many atoms were present. Well, we don't have charges here because molecules share electrons, so we're going to have to use prefixes in order to tell how many of each atom are present. Now this is your list of prefixes. The prefix for 1 is mono, 2 is di, 3 is tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 is deca. So here are the examples I showed you on that first slide. If we were naming this, we see that there are 2 nitrogens, so that's dinitrogen, and there are 5 phosphorus. So we use the prefix penta, and remember we changed the ending of phosphorus to IDE. So it's dinitrogen pentaphosphide. In this example, CCl4, we have 1 carbon and 4 chlorines. Now notice, even though the prefix for 1 is mono, we never begin a name with mono. So we're not going to write monocarbon. It's just going to be carbon, and then for the prefix 4, we'll write tetra, and we'll change the ending of chlorine, we'll change the ending to chloride. So that's carbon tetrachloride. Now there are a few little tips. One of them I've already shared with you. You never begin a name with mono, but you will write mono on the second element if there's only one. So for example, you're familiar with the molecule carbon dioxide. Notice we don't call this monocarbon dioxide. Never begin a name with mono. The second tip is that you always want to drop the O or A on a prefix that comes before oxide. So notice for this formula, this is not sulfur tetraoxide. We drop the A on tetra, so it's just sulfur tetroxide. Now when you write the formulas for molecules, you're going to just do whatever the prefixes tell you to do. You're not going to write down any charges, you're not going to crisscross, you're simply going to follow the prefixes. All right, so I'm going to switch over to my document camera now, and this is the practice worksheet I've given you to do for this concept, and I'm just going to do a few of these with you. If you look at number 2, we have 1 carbon and 1 oxygen. So we never begin a name with mono. So I'm just going to write carbon. But for the second element, oxide, since there's only 1, I am going to write monoxide. Skipping on down to number 7. We have 2 nitrogens, so that's dinitrogen. And then the prefix for 3 is tri. oxide. So notice the ending of your name is always going to be "ide." And I'll do one more from you from this side. If you look down at number 13, you have 1 nitrogen and you have 3 hydrogens. So that's trihydride would be the name of that. All right, if you flip this sheet over, it says writing formulas from names. This is actually a mixed review, meaning you have ionic and covalent on this side of the sheet. So the easiest way to identify if it's covalent is, like we just said, it's going to have 2 nonmetals. And since you're writing formulas on this side, what you're really just looking for is anything with prefixes. So if you look through ammonium phosphate, iron 2 oxide, iron 3 oxide, none of those have prefixes, but when you get to number 4, we see a prefix. So this means it's a molecule. I'm going to write C for covalent, and all I do is follow the prefixes, carbon monoxide. So you'll do that for all of the ones that have prefixes. For the rest of them, you're going to use the same procedures we used for ionic. So I'll do the first 3 examples with you. For ammonium, that's NH4 plus 1. Phosphate is PO4 minus 3. So remember, you have to cross the 3 and add parentheses. So that'll be NH4 parentheses 3 PO4. For iron 2 oxide, that Roman numeral tells us that iron has a +2 charge. Oxygen, we know, has a -2 charge because it's in group 6. +2 -2 cancels out, so we don't need to do any crossing. We would just write FeO. And then iron 3 oxide, iron has a +3 charge. Oxide is still -2, so we have to cross our 2, cross our 3. So that's Fe2O3. All right, so that's all the examples I'll do, but if you have any questions, please let me know.